Hello and welcome to Elevate 24 into 7 again. This is Chetan Patel. In this particular video, we are trying to understand different number systems. Okay, fine. Uh, First, we'll discuss about decimal number system. Okay, when it comes to decimal number system, okay, see here we're gonna use only 10 digits. Deci means 10, right? So 10 different digits to represent any number. Okay, we use 0, 1, 2, 7, 8, and 9. So we use only these digits to represent any number, any number. Okay, that is what decimal number system. Okay, and one more thing, as I told you, suppose if I take 526, okay, here each and every digit in this number can be represented with the help of powers of 10. Okay, so like I can write this pi in powers of 10, which is 10 square, and 2 with powers of 10, 2 power 1, and 6 in 10 power 0. Okay, you know that anything to the power of 0 is 1, I think, where x is any number in fact. Okay, except 0, right, where x should be greater than 0. Fine. So this is what the decimal number system. To count any number, we gonna use only these digits. Okay, and every digit in that number can be represented with the powers of 10. Okay, this is what decimal number system. Now we'll try to understand binary number system. Okay, binary number system, here we use only two digits. Okay, 0 and 1. Okay, so but in decimal number system we use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, in binary we're going to use only two digits, which are zeros and ones. Okay, fine. Suppose, let's say, I wanted to tell you this thing. Please observe very carefully and try to identify the difference between decimal and binary when I am writing it. Let's say if I take this binary number, okay, this is decimal number system. Okay, right? If I take binary number, something like 10 and 10. Okay. So now, what exactly the value of this 10 and 10? Okay, that is what we'll try to compute. Okay, the same method. See, what actually happens when we are actually expanding this 526, okay? I take this 5, and what I have done, I multiplied. Since this is decimal number system, we have 10 different digits. I need to write 10 somewhere here. And if I start numbering it, it is there in the zeroth position. This is first position, and this is second position, right? So since 5 it is there in the second position, I should give a rise 2. Okay. And similarly, when I comes to 2, okay, 2, and it is present in the first position, and I should give rise 1. And 6, it's there in zeroth position, I should give 10 power 0. So this is the again one more type of meaning to it. Okay, if we employ the same technique to this, okay, how can we write it? We'll write 1 into, okay, since we are working with binary number system, here we only use two different numbers, two digits. Here we gonna use 10 digits to represent. Okay, right? So I should write 2 into, okay, so what is the positional value of this one? Is this is zeroth position, this is first position, this is second position, and this is third position. Okay, so I should write something like 2 power 3. Okay, plus 0 into, in the similar fashion I am writing. Okay, okay, 0 into this 2 into this 0 is present in the second position, 2 power 2, plus again let's take 1 into 2 power, this is there in first position, plus 0 into 2 to the power of 0. So now, if you just write this 1 into 2 power 3, 1, 2 cube is nothing but 8, plus 0 into anything is 0, plus 1 into 2 power 1, which is 2, into 0. Okay. So this is 8 plus 2, which is 10. Okay. So if 1010 is there in binary, this equivalent decimal number is 10, which is there in base 10 system. Okay. So this is what binary. Okay. How we can write binary number system? I want you guys to understand very neatly. Okay, so converting binary to decimal, decimal to binary, again we will be discussing in a separate video. But so this is just a concept of decimal number system and binary number system, how actually they work and how they arrive. Okay, so this is what we need to understand. Okay, so in the similar fashion, if we try to understand octal number system, I think you guys can guess it. The same approach will be used in octal. Octal number system, we use 8 digits. Okay, starting from 0 to 8, 0, 1, 6, 7. Only this number system. Let's say if I have something like 989. Okay, so this can't be octal number system. Why? Because it use 989, which are not which are not the digits. Okay, when that we're gonna use when we're actually representing a number with octal number system. This is not an octal number. Okay, so something like this. Okay, so if any number is six something, if it is there, okay, and if it is not represented with anything, something like 6765. Okay, so we call this as decimal number system. Okay, decimal, even though it is there in 0 to 7. Okay, but when comes to 675 base 8, something like that, if explicitly mentioned, so then we call this number is there in octal number system. And the actual value of 765 is very different from the decimal number system. We will try to convert this to the decimal number system for sure now when we're now itself. But people don't need to confuse with this. Okay, so if any number is written, let's say 789, and obviously if it is not mentioned with the base something like 10 or 8, something like that, you don't need to confuse. Obviously that is decimal number system. Okay, because we are not specifying anything, so this is a very common way. But if anyone is representing this with something like this, then only we can consider that particular number is there in octal or something like that. This is just for the notation, because more often we always used to work with the decimal number system. Okay, fine, that's fine. So now we'll try to understand how we octal number system works. Okay, okay, fine. So suppose if I have a number something like 6765. Okay, so this is there in octal. Okay, so now how we will expand it? Okay, the same rule that we followed over here. Okay, what we do first, we'll pick the first. We'll just give a number, zero positions, first position, second position. We'll first pick a first digit, which is 7 into. So since we are working with octal number system, we need to give 8 raised to. Okay, plus we'll pick the second digit, which is 6, and right. So I can give 8 raised to 1. Okay, and 5 into 8 raised to 0. Okay, if you do like this 765 can be converted directly into the uh, uh, decimal number system. Okay, so what essentially we need to do now, 7 into 8 square is 64, plus 6 eights are 48, plus 8 8 to the power of 0 is 1. Okay, 5 ones are 5. Okay, so I wanted to compute 64 into 7, correct? So 4 sevens are 28, carry 2. 6 sevens are 42 plus 2, which is 44. 448 plus this 48 plus 5. Okay. 8 plus 8, 16 plus 5, which is 21, carry 2. Now on 4, 4 plus 4, which is 8. 8 plus 2 is 10. 0, carry 1. Okay. 4 plus 1, 5. Okay. 765, when we convert into the decimal number system, so this is just like 501. Okay. So this is there in decimal. Okay. 765, if it is there in octal, the equivalent decimal number system, decimal number to it is 501. Okay. How octal number system works well. Okay, so here we are gonna only use these numbers. Okay, next we have something which is again very important. Okay, hexadecimal number system. So here we use okay, we use the digits from 0 to 9. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and okay, we use the English alphabets from A to F. Okay, like A, B, C, D, E, F. Even though we are using the English alphabets over here. Uh, so this A represent a number 10, okay, and B represents number 11. It is represent 12, 13, 14, and 15. Guys, you just remember. I think you just try to remember it. Okay, so fine. So in hexadecimal number system, okay, a number can be represented by the combination of numbers from 0 to 9 and as well as the alphabets from A to F. Okay. So this is something which is very unique. So hex means 6, deci means 10, 10 plus 6, which is 16. You're going to use in total 16 digits, okay, to represent it. Okay, that you must be aware of. Okay, that's great. So now let's try to convert this one AF is there in hexadecimal number system. Okay, because it contains AF and as well as one, which is belongs to this particular set, and AF is there in English alphabet. Okay, so this is there in hexadecimal, which is base 16. Okay, so if I wanted to convert this to the decimal number system, okay, what I need to do, the same procedure for everything. Okay, in here we are using 16 different symbols to represent a numbers. Okay, so I'll take one and I'll multiply this with 16. Okay, the position of this one is represented by 2012. Okay, you need to start numbering from right to left. Okay, so 16 to the power of 2. Okay, plus a, as I told you, this a represent number 10. Okay, fine. So I'll take this a as 10 into 16 to the power of 16 to the power of 1, because a is present in the first place, which is 16 power 1. Okay, fine. And f is nothing but 15, and it is present in 16 to raised to 0 position. Okay, so 16 square I know, which is 256, plus 10 into 16 is 160, plus 15 into 1 is 15. So I need to add 256 plus 160 and 15. So which is 11. 6 plus 6, 12. 12 plus 1, 13. Carry 1, which is 4. Okay. So 431. Okay. So the equivalent value, decimal value for this hexadecimal 1A F is nothing but 431. It is there in decimal number system. Okay. So this is what hexadecimal number system. Okay. So just for a quick revision. Okay. So we have decimal number system which uses digits from 0 to 9. Okay. And in total we're going to use 10 digits. Every digit in that particular number, okay, uh, represents, okay, represent the place value. Okay, place value in raised to the power of 10, or in powers of 10. Okay, in binary number system we use digits 0 and 1, and we use two digits, and every digit in the binary number system represent the uh, represent the place value in powers of 2. Okay, right. So and then in octal number system we use digits from 0 to 7. Okay, and here in total we're going to use 8 digits, and every number, or sorry, every digit in that particular number represent the place value in the power of 8. Suppose if I take something like 560, so which can be octal number system, here pi represents, okay, the place value of this 5 can be represented by 5 into 10 to the power of 0, 1, 2, 10 raised to 2. Okay, sorry, 8 raised to 2, which means that every digit in that number, okay, can be represented with the help of the powers of 8, or the place value of this 5 can be represented with the power of 8. Okay, fine. which is essentially here power of 2, because 5 is there in the second position or 100th position. Not exactly 100, I should say. I can say here is 8 square, which is 64th position, I can say. Okay, fine. And again, when it comes to hexadecimal, here we use digits from 0 to 9 plus A to F. Okay, in total we're gonna use 16 digits, and as usual, like every digit in that particular number, okay, represent the place value in the powers of 16. Okay, that is what why I'm thought place value, because you already understood the concept of place value in the previous video. If you didn't understood, please go and check out. Okay, so now in the next video we'll discuss about again how we can convert binary number system into the decimal number system and decimal to binary number system. Okay.